So this is exponential functions. Exponential functions. And then when we look at, okay, let me write exponential functions. So I'm just going to show you how basically we deal with that question that I've just said you must do. So that question is an exponential function questions, and then it says sketching exponential graphs. So they're saying consider the graph y is equals to 2 to the exponent of x. So they're giving you the graph y is equals to 2 to the exponent of x, 2 to the exponent of x, and another one is what? We're also having what? The graph of y, it's equals to 1 over 2. 1 over 2 to the exponent of x. And then they're saying a set of x values to the exponent of x. And then they're saying a set of x values which is -1, 0, 1 have been selected, and the corresponding y value have been calculated in each case. And then the graph is shown on the right. So actually this question it was already done, but I wanted you guys to do it as part of an example. So let us draw this equation, which is us drawing these two graphs. So y is equals to 2 to the exponent of x, as well as y is equals to what? Half to the exponent of x. Remember, both of these two graphs, we call them exponential functions. How do I know that it's an exponential function? An exponential function, you see it with the equation y is equals to a multiplied by b to the exponent of x. So each and every time you can get the equation in this form, you must remember that that is the equation of an exponential function. Please let us not move the screen, guys. Ne? Because you see now, I'm writing, someone is moving the screen. Never move the screen. So that is it. I hope all of you can see. So it means to say we're going to draw those two equation of the exponential function. But the thing is that we can't draw both of them on the same system of axes because an exponential function must have an asymptote. So what I'm going to do, I'm going to say y is equals to 2 to the exponent of x. And then we're going to draw a table of values. Remember, I told you to say there are two ways in which you can draw a graph. Number one, you can use the table of values, which is the one that I'm using, whereby here we are having x, there we are having y, right? And then when you check there, they're saying a set of x values, which is what? Which is going to be -1, 0, as well as
Sorry
1.
to disturb, sir.
Yes,
Sir,
yes.
very sorry for disturbing. I cannot see anything.
You cannot see anything. It's because of, okay, it's because of the, maybe you were moving the screen. Okay, let me just try
I
to check.
don't move the screen.
Michaela, do you see the screen? Michaela, can you see the screen? Okay, Nola,
Sir,
do you see now?
let me try to zoom in.
Okay, please do that so that we can proceed.
I can see now. Thank you.
You can see now?
Yes.
Okay. Michaela, can you hear me? Okay, let's continue, guys. So these are the x values that they actually gave you. So what you're gonna do, you're gonna do this aside on a scribbler by just writing y is equals to, that is 2 to the exponent of x, that is the equation that we are having. And then I'm gonna say for for what? For x, it's equals to a -1. This basically means to say I'm gonna rewrite this equation right here, which is y, it's equals to 2 to the exponent of x. Then after that, in the place of x, I'm gonna put -1. So it will be y, it's equals to 2 to the exponent of -1. Therefore, your y is gonna be 1/2. It's gonna be 1/2. It's gonna be 1/2. So here we're gonna write 1/2. And then we do the same on a scribbler with a pencil. You write the equation of an exponential function, which is what? Which is y, it's equals to 2 to the exponent of x. And then after that, it's gonna be y, it's equals to, remember here, you're gonna say for x is equals to 0. For x is equals to 0. When you're saying for x is equals to 0, it means to say where there is x, you're gonna put 0. So that will be 2 to the exponent of 0. And then you know that anything to the power of 0, the answer is 1. So here we're gonna write 1. And then you rewrite the equation again, which is y is equals to what? 2 to the exponent of x. Then after that, what you're going to do, you're gonna say for x is equals to 1. And then that will be you writing y is equals to 2 to the exponent of x. And then in a place of x, you're now gonna put 1. It's gonna be y is equals to 2 to the exponent of 1. And then after this, here we're gonna say therefore the value of y is equals to 2. So that 2, you're going to write it there. Then after that, you're now going to draw your graph. When you're drawing your graph, make sure that you are having a Cartesian plane. So that is going to be 1, 2, 3, 4. And that's going to be 1, 2, 3. That's going to be 1, 2, 3. Remember, this is 1, 2, 3. All of these are negative. Then that's 1, 2, 3, 4. That's 1, 2, 3. And then this one we know that we call it the what? We call it the y-axis. Then this one we call it the x-axis. Then after that, it's now a matter of you doing what? Now plotting the graph. So when our x is -1, it goes hand in hand with the half. So our coordinate is gonna be somewhere right there. Then when x is 0, it goes hand in hand with 1. So our coordinate is gonna be right there. Then when x is 1, it goes hand in hand with 2. And I have another coordinate just right there. Then from there, what you're going to do, you're gonna join those coordinates. So you're gonna have a graph that it's like that. So this graph, one thing that you should never make a mistake of is that this graph, it should never touch this graph should never touch the x-axis. You know why? Because the x-axis x as our asymptote. It's x as our asymptote, so it should never touch that. Then after that, you can now label your graph to say that is y is equals to 2 to the exponent of x. Then you are done drawing your exponential function, just like that. Any question? Any question? Any question, guys?
No question, sir.
Okay, since there's no question, we can now proceed. So that's how basically we're dealing with that. So it's very important that you know how to draw that graph, because it's a typical exam question. They'll ask you to draw the graph. So after that, now we are done drawing the graph of y is equals to 2 to the exponent of x. The next thing that we are going to do now is draw this graph, which is y is equals to 1 over 2 to the exponent of x. So we must draw that graph now. So we're gonna draw it on a separate system of axes. So we're gonna say y is equals to 1 over 2, 1 over 2 to the exponent of x. Remember, they told us about using the following x values. So that is x here, that is gonna be y. Then they said, let me check. They said we must start at -1 ending at up. So it's gonna be -1, 0, as well as 1. Right. Okay, before we can continue drawing this second graph, let's go back to the previous graph and then write the domain and the range. Because in maths, they will always say write the domain and the range, taking in consideration that them telling you to write the domain and the range, they know that you will have drawn the graph. Ne? So let's write the domain and the range. So when we speak about domain in maths, guys, we are speaking about all the x values, and then range, we are speaking about all the y values. So the domain, in this case, it will be x, an element of real numbers. You know why I'm saying x is an element of real numbers? It's because of when you trace this graph, to those who don't know, real numbers, it simply means to say it includes all the negative as well as all the positive values. So this graph is coming from negative infinity, going up until positive infinity, just like that. That's why my domain right here, I'm just saying it's x, an element of real numbers. And then there's another person who can write the domain like this. We'll just say domain. We'll say domain x is an element of, we'll say x is an element of, let me write it properly. There's someone who will write the domain and say domain, it's x is an element of negative infinity up until positive infinity. X is an element of negative infinity up until positive infinity. The reason why we are saying that is because of, Uguti, you saying negative infinity up until positive infinity, you know how your graph moves like. So this basically means to say you can just say x is an element of negative infinity up until positive infinity. So that's how basically we write the domain. So we'll just say x is an element of negative infinity up until positive infinity. And Michaela and the rest of the guys, one thing that you should know again, the reason why here we are using what? The reason why we are using a small bracket, even this side we are using a small bracket when we are writing our domain, is because of we only use a small bracket if we don't know where the graph is coming from or where it's ending. So that's how basically we deal with that. And then now this, because if you write it like this, you're still correct. Even if you write it like that, you're still correct. Now let's deal with the range. So when I speak about the range, it's all possible values of y. So range, I speak about all possible values of y. Range, it means all possible values of y. So you'll just say y, you'll just say y is an element of real numbers. Y is an element of real numbers. You'll just say y is an element of real numbers. So range will say y is an element of real numbers, comma, where y is greater than 0. Or someone can just write it like this. Someone will say the range is y is an element of what? Y is an element of praise 0 to positive infinity. So it's going to be 0 up until positive infinity. Then you write a small bracket right there. So it doesn't matter which concept you have used, as long as you are writing right things at the end of the day. So we are done with regards to the domain as well as to the range. So now we are coming back to drawing this. So now as we are drawing the second graph, remember we must start by writing the equation here to determine the values for us to get the coordinate pairs. So it's going to be y is equals to, you write y 1 over 2, and then to the exponent of 1 to the exponent of x. And then here you're just going to say for x is equals to -1. You're going to say for x is equals to -1. So we're just going to say for x is equals to -1. Then we're writing that. Let's now solve, or let's now get the answers. Let's solve, or let's all get the answers. So you're just going to say 4. Why is my screen loading again? Okay, just a second. Can you all see my screen, guys? Because it's loading on my side. Can you all see my screen? Can you guys see my screen? Can you guys see my screen? Can you all hear me, and do you guys see my screen? Oh, there we go. Okay, let me try to remove my screen. Oh, we're almost there. Sorry for that. So as I was saying right here, is that here I'm gonna say for x is equals to -1. Then you rewrite that equation being y is equals to 1 over 2 to the exponent of x. And then we're gonna say y it's equals to, then in the place of x you put -1. That will be 1/2, then -1. Just like that. Then you're gonna say therefore y is equals to, now let's press that on the calculator. Let's see what do we get. So you're gonna say 1/2 to the exponent of -1. 1/2 to the exponent of -1. 1/2 to the exponent of -1. So what's the answer?
It's 2.
It's what?
2.
2.
Yes.
Yeah, it's gonna be 2. So you write 2 there. Then that 2 you're gonna go and write it there. Then you do the second one. You rewrite the equation y is equals to 1/2 to the exponent of x. And then that will be y. It's equals to, so that will be 1/2. Then to the exponent of, now we're gonna put 0. Therefore, y is equals to, we know that anything to the power of 0, the answer is 1. So we're gonna write 1 there. Then after that, we continue writing the equation, which is y is equals to 1/2 to the exponent of x. And then here you're gonna say y is equals to, that will be 1/2. Then in the place of x, we're gonna put 1. Therefore, y is equals to, that should be 1/2. So here we're gonna put 1/2. So there you're gonna put 1/2. And then with that being said, you're gonna plot your graph. You plot the graph nicely, so that will be 1, 2, 3. You write 1, 2, 3. Then that will be 1, 2, 1, 2, 1, 2. Then that's 1, 2. So this one is the x-axis. This one is the y-axis. Then now you are plotting your graph. So -1, it goes hand in hand with 2. So where there is -1 and 2, where they meet to make a dot, then 0 goes hand in hand with 1. So where they meet to make a dot, then 1, it goes hand in hand with half. Where they meet to make a dot. So do you know that? Can you see that you're having those 3 coordinates? Now you join them. So as you're joining them, you're gonna have a graph that moves like that. But your graph should not touch the x-axis, because the x-axis acts as an asymptote. So it basically it basically means to say, if, since now you can see the difference of these two graphs, if I were to draw them, it means to say these two graphs, if I were to draw them on the same system of axis, remember this one, remember the other one, it moves like this. It means to say here, that will be the common coordinate. So those two graphs, if I were to draw them, they were gonna move like this. You now see, but take in consideration that these two graphs that you are drawing, they should never touch the what? They should never touch the x-axis, because the x-axis acts as an asymptote. So this basically means to say the green graph is given by what? Let me double check. The green graph is given by y is equals to 2 to the exponent. So you're just gonna say y is equals to 2 to the exponent of x. And then the yellow graph is given by the equation y is equals to 1 over 2 to the exponent of x. So what is very important is that on these two graphs, they meet here. This is the point of intersection. That's where they meet, which is this coordinate. We consider that as the what? We consider that as the y-intercept. So that is the y-intercept. So the y-intercept of these two graphs is gonna be 1 right there. So this is how basically you draw these two graphs. And the domain and the range, they're gonna be the same. Even if you were to draw the domain of the what? Of the yellow graph, you're gonna have the domain being what? X is an element of real numbers. Because the graph has all the negative values as well as the positive values. And then the range, what would be the range? The range will be y is an element of real numbers, comma, where y is greater than 0. Just like that. So this is how basically we draw these graphs, because it's very important to knowing how to draw the graph. You being able to draw these two graphs, you stand a chance into making sure that you get a distinction. Any question? Any question?
No, sir.
Okay. So if there's no question, we'll have to end up on these two examples. But before that, there's something that I want to show you. Isn't it that now I'm saying this coordinate right here, it represents the y-intercept, which is 1. I want to show you. And here we know that in functions, if you want to get the y-intercept, what do? You're just gonna say y-intercept, comma, let x is equals to 0. And here when you get the y-intercept, or let x is equals to 0 and solve for y. And then in that case, you write the equation y is equals to 2 to the exponent of x. And then when you're saying y-intercept, let x is equals to 0, where there is x, you put 0. So it's gonna be y, it's equals to 2 to the exponent of 0. Therefore, we know that in maths, anything to the power of 0, it's 1. So it's gonna be y, it's equals to 1. So do you see where we are getting 1? It's because of this one here. It represents the y-intercept. Why is it representing the y-intercept? It's because the y-intercept in maths is the point on the graph where the graph passes on the y-axis. So you're gonna check the y-axis, which is this one. The only point on the graph that passes on the y-axis, it's y is equals to 1. That's why here we are saying the y-intercept is y is equals to 1. Even if you were to find the y-intercept using the second equation, you are still gonna get the same answer. Let me show you how. And here you're gonna write that equation, which is the equation of the second graph. And here you y-intercept. You say y-intercept, comma, let x is equals to 0. So when you're saying let x is equals to 0, you're gonna write the equation of the second graph, which is y. It's equals to what? 1 over 2 to the exponent of x. Not only that, now the next step, what basically you will do, we are substituting as 0 where there is x. So it's gonna be y, it's equals to 1 over 2 to the exponent of 0. What happens? In math, you know that anything to the power of 0 the answer is 1. Therefore, here, we're going to have y is equals to 1. Do you see? Why? Because these two graphs, they meet at 1. It means to say, for this equation, even if you want the y-intercept, you're going to get the very same y-intercept you using the second equation. All these answers, they're going to be the same because these two graphs, they meet at 1. So there's no way you can get the y-intercept not of 1 in this kind of scenario. So this is how we draw these graphs, and make sure that you practice functions because functions, they carry a lot of marks. Functions, they really carry a lot of marks. And if you want to get a distinction, you must start by doing what? You must start by practicing. Why should you start by practicing? Because practice makes perfect. So there's no way you can master this without practicing this. So it starts by you practicing. It starts by you putting in the work. It starts by you asking questions. Any question, guys? Any more question? If there are no more question, it means to say we are done. Thank you for joining. Make sure that you continue to practice because practice makes perfect. Sharp, sharp, guys.
Bye-bye, say.
Bye-bye.
Your name is the highest. Your name is the greatest. Your name stands above. Ukuthi umuntu uyakuthanda. Ngenani ezime. How certain are you as a Hey. Hi everyone, this is 𝗘𝘅𝗽𝗍𝗂 first training with the team. We had a morning session. I just see you in the afternoon session. Thank you very much. Hey. Hi everyone, this is 𝗘𝘅𝗽𝗍𝗂 first training with the team. We had a morning session. I just see you in the afternoon session. Thank you very much. Hey. Hi everyone, this is 𝗘𝘅𝗽𝗍𝗂 fun.